Now let's talk about variants. What are variants? Variants meaning there are several options. When we discussed arithmetic expressions in the beginning of this semester, we said that arithmetic expression is an expression that represents some arithmetic, right? Mathematical expression. And because our language is really primitive, it has only 3 cases: number, addition, or subtraction. Meaning, a number is an arithmetic expression. Arithmetic expression plus arithmetic expression is an arithmetic expression. Arithmetic expression minus arithmetic expression is again this one. Meaning, there are 3 variants. FAE has name, function expression, and function call. So 3 more variants. Altogether 6 variants. They are variants. Let's think about direction. If it's just one dimensional, there's only left or right, right? So left meaning that when we get a number of steps on the left, we are going to return a pair of the direction and the number of steps. So left is a function which takes a number, produces a direction with some amount. So left is a function which takes a number and produces a pair of left and how many steps. So 0 meaning left. Right is yet another function which takes a number, produces a pair of right and how many steps. Right is a function which takes a number of steps and produces a pair of right direction with these many steps. Displacement takes amount, right? Takes that direction and an amount and produces the location. Displacement takes a pair and the first component denotes left or right. Second component denotes how many steps. So what it does is to check whether the first component of the pair, meaning p.1, whether that's 0 or not. If it's 0, meaning left. So if it's 0, then 0 minus p.2, how many steps? If it's non-zero, meaning 1 in this case. If it's non-zero, then these many steps on the right, meaning left is minus and right is plus. So when we have left 5, what do we have? When we have left 5, left 5, meaning x is 5 and we're going to return what? 0, 5. When we call displacement using this pair 0, 5, p is going to be 0, 5, p.1 is going to be 0, p.2 is 5, and because p.1 is 0, meaning it's on the left, 5 steps on the left, so displacement is going to be minus 5. So far, so good. Then, the second example, variance. We are giving you grade. You know what? This semester we have that COVID-19, that pandemic situation, several courses have this pass or fail or pass or fail and ABC. In this course, we are going to have only ABC. But let's assume that our pass depending on either grade or pass or fail. Right? There's an option. Oh, it's really good to explain this because in the usual semester, students didn't get what that means. But this semester, you can understand that, right? Pass meaning it's either pass or not depending on your grading system. If you prefer to have ABC, then you need to see the score. If you have pass or fail results, 그걸 뭐라고 하지? 학점 인정 시험을 먼저 봤을 수도 있죠. Then we are gonna use that, meaning that grade, it takes a number of your score. Say midterm exam score, final exam score, or average of that, whatever. Grade takes a number of your score and then makes a pair of a number and another pair. Why? Previously, it was left or right, but how many steps on the left, how many steps on the right, meaning the number of steps, both of them were numbers. This time, we have two options, grade or pass or fail. Grade meaning your score number. Pass or fail meaning pass or fail, Boolean value. Depending on which one you pick, it's going to be either number or Boolean. Do you see that? It's a variant, grade, or pass or fail. Either this or not both. 둘 다 가질 수 없어요. 둘 중에 하나만 가지셔야 돼요. You need to pick one, but one has type number and the other has type Boolean. Did we say that in this simple language we cannot have different types for two branches? Yes, right. So what we are trying to do is to have both as a pair. And if you pick grading, the other is going to be garbage. If you pick Boolean, then the other number is garbage. Do you see what I mean? Let's see what I'm talking about. So grade, it takes a number and makes a pair of 0, meaning, this is for grading. And then the result, the value is a pair of that score and false. Always false. Pass fail is going to be always false because if it's grading, we are not going to read it. If it's pass or fail, it takes that Boolean value, pass or fail. It takes a Boolean value, pass or fail, and makes a pair saying 1 for pass or fail, and then a pair of the garbage 0 that we are not going to use when we choose this case, and actual pass or fail. How do you use that? Pass her, question mark meaning her. Pass her. Is it passing or not? And take the thingy. The thingy is either 0 and the score or 1 and pass or fail thingy. So if the first tag, the p.1, the pair.1, the first thing is 0, then it's grading. So we need to check the second component's first component. The first component of the second component. Do you see that? And, see, the cut line for pass or fail is 70. Really bad, right? Really tough. So, if your grade is higher than 70, then you are passing. Otherwise, you are failing this course. If that's P.1, the first component is non-zero, then we are going to check, we're going to get the second part of the second component, whether that's true or false. Do you see that? So finally, this grade 96, what does it do? Grade 96, grade takes a number 96 and produces what? 0, 96, false. And then pass her, meaning, hey, pass her. Let's take the pair and see whether the first component is 0 or not. The first component is indeed 0. Then we need to check the second component, which is that. And the first component of that, which is 96, is greater than 70. That's good. Then you are passing. Congratulations. Are you with me? Then, we can work on this thing. We can simulate this either grading or a pass or fail, but we had to make up a value for the other type, which is garbage, right? When we have grade, we always had this false that we do not use. When we have pass or fail, we always had this 0 that we are not using, garbage value to make a pair. So yeah, it's wasting the memory, but it's doable. Let's look at the third example that we cannot even simulating that. Recursive data types. Let's think about lists, that our beloved data structure list. List is a variant, right? We talked about that from the beginning of this semester, saying that list is the best data structure in functional programming, which is defined inductively, mathematically beautiful, meaning it's either empty or not. Empty or not. Empty does not have any information, right? And cons has at least two pieces of information. The first element had, or the second element, meaning the remaining list. The remaining elements. That's it. Because the remaining thing, the second thing is again list. It's recursively, inductively defined. That's cool. Can we simulate that in our simple typed language? Not really, right? Because either empty or cons, we learned that we need to make it as a pair of number and some thingy, right? And if it's a zero, it's going to be empty. If it's one, it's going to be cons. But what can we have in the second part? It's not doable. We cannot type check this, meaning we cannot write anything working in these ... Lists are really useful and really good, and we'd like to accept this. We'd like to support this data structure called list, but it's not that simple. What can we do? In Scala, remember, we defined a type named numList, a list of numbers, and it indeed has two variants, empty or cons. Empty, again, does not have anything in it. Cons has two pieces of information, the first element number and the remaining elements. When we define this inductively defined type, we can look at it. We can perform pattern matching on it, right? So this length, right? Length for length. Length function takes a list of numbers and count the number of elements in the list. That's called the length. Then, hey, you argument LST for list, right? List. Are you empty or not? That's it. That's exhaustive. Because there are only two cases, right? So we didn't miss any case. Then empty, or then the number of elements of the empty list is 0. If it's not empty, that should be cons, and that at least has one element. So let's say 1 plus the length of the remaining list. So far so good? Yeah, very simple. Then what can we do? We can construct empty in this way. We can construct a cons this way, meaning it has 2 on top of empty. So it's a singleton list. And we can add 1 on top of that. So this is what? 1, 2, empty. And the length function can take this list and count the number of elements. Interesting, right? Okay, then that's a Scala program. And what about our language? In this new language for today, we are going to add 2 language constructs. One for defining type, right? And the other to use type. One for defining user-defined type, and one for using a value of that type. So the typical example is numList, a list of numbers. Type is a keyword saying that we are defining a new user-defined type. This is a name that has two variants. The name of the first variant is empty, and the name of the second variant is cons. And every variant has at most, or exactly, at least and at most, meaning exactly one field. Even though empty does not have anything in it, even though we do not need any element for empty, we need to have some field in this language, because this language is so primitive. I will talk about that a bit more in the next slide. And cons, even though it has two components, right? The first element and the remaining thingy, it has only one field. But it's okay because that field could be a tuple, a pair. So far so good. One more time. We defined a new type named numList, which has two variants, empty and cons. Each of them has only one field. This num is not going to be used in anywhere, just garbage, to have this one field. And cons has a pair of the first element and the remaining elements. How can I use that? Just like the previous len function example in Scala, we can define the len function in this language. Define the recursive function len, which takes a parameter of type numList. And because it counts the number of elements in a given list, the return type is going to be num. What's going to be the body? Let's perform the pattern pattern matching on the input list. Hey list, I know you are numList. Because I defined it that way, I know you have only two variants, empty and cons. And because I defined that in that way, I know empty has only one field, cons has only one field. And empty is not interested in its field, and the number of elements in the empty list is 0. For cons, I know this one single field is actually a pair, right? And the first component is the first element, so we just count the number of that. And we want to know the length of the remaining element, which is p.2, the second component of this pair. So far so good. So we can construct an empty list by saying empty 0. And we can construct a singleton list with one element, which is 2, like this. And we can have another list this way. And when we call this len function using this value, what can we do? What happens? Oh, okay, let's do this one more time then. Empty with number. Oh, yeah, let's do this trick. Not trick, quiz. What's the type of 0? That's num. What's the type of empty? It's a really good question, right? What's the type of empty? You should be able to answer this question. Empty, it's a function, right? Empty takes a number and produces what? Meaning empty 0, what's the type of the whole thing? Empty 0, its type is numList. So empty itself is a function which takes a num and produces numList. Right? Are you with me? So then, empty 0, empty 0, its type is numList. Let's do one more time. What's the type of cons? Cons. Cons is a function. It's a function which takes a pair of num and numList and produces what? NumList. So this cons takes a pair of number and num list and produces num list. That's why the whole thing from here to there, its type is num list, right? You should be able to do that by yourself. Because the whole thing is num list, we can call this len function, which expects a num list, which expects a num list. Yeah, that's num list. Produces what? Number. So the type of the whole thing is number, right? Yeah, you should be able to do that by yourself. Then, this is the language for today and next Monday. FAE with type and variant. TVFAE. Yeah. FAE with type and variant. FAE with recursive function and if 0. And now we added two language constructs, type definition and type use. Type is the keyword claiming that I'm defining a new type, a new user-defined type named T. So T is a type. Okay? What is T? What is num list? Oh, you know what? It's a variant. It has two variants named X and X1 and X2, X and Y, empty and cons. And they have only one field whose type is tau1 and tau2. That's our new type. And then we interpret this expression. While evaluating this expression, we may use T and X. Okay? Then, how can we use that? By using pattern matching. When we interpret this expression E, its value is going to be either empty or cons. Right? Empty or cons. If it's empty, it has only one field of type this. Of type this. If it's cons, then it again has only one field of type this. If it's empty, evaluate this. If it's cons, evaluate that. That's the semantics. Are you with me? So we defined a new type T. We added two language constructs to define a new type T and using a value of that type. So the type language is now extended with the third kind, which is T, type name. And T is a type name. Okay? Okay? So what's the limitation of this language? How is it different from Scala? How is it different from other languages with variant types? Think about it. What do you think? Yeah. Here, the type, user-defined type in this language should have only two variants. So we cannot say type AE equals num add, say num plus add pair of AE, AE. Oops. We don't have a pair in this language, but we can add it, right? Plus subtraction with two thingy. We cannot do that because it has only one plus. Are you with me? Another thing, we cannot have these two fields here unless we add pair here. Right? Let me repeat what I just said in Korean and in English and then take a break. 지금 이 언어는 타입을 만드는 걸 배웠어요. 여러분 이제 많이 배웠죠? 언어가 막 타입도 정의해요. 그런데 이 언어가 조금이라서 이 타입은 항상 베리언트가 2개밖에 없고 각각의 베리언트는 꼭 필드를 하나씩만 가져야 돼. 안 가질 수도 없어. 그래서 심지어 empty까지 그걸 가져야 돼. 그죠? 그리고 항상 2개밖에 못해요. 2개밖에 못하면 어떻게 3개 하고 싶은데 그러면은 어떻게 하면 되지? 인베드를 하거나 나중에 확장을 하면 되겠죠. It's your what? Homework or exercise. Again, this language is primitive, so even though it can define a new type, that type should have only 2 variants, and each variant should have exactly 1 field. It cannot have no empty, it cannot have more than 2 fields. More than 2? Yeah. But if we have pair, then we can support that. But syntactically, every variant has only 1 field. And if you want to have more expressive power, you can extend that, right? That's it for the second part. And let's have the last part of today's lecture.